In this lesson, we're going to talk about logarithmic and exponential equations and how to solve them. So the definition of logarithms is going to be your best friend. I'm actually going to write it a little differently than is in your notes because I think it's important to remind yourself that what these things mean. So log base b, usually we do x equals y, but instead right now I'm going to say log base of the number is equal to p for power, okay? That means if you take a base to the power, you get a number. And these mean the same thing. So, that's going to be really helpful when solving these equations. Can you write it the other way in order to be able to solve? Then we were looking at the properties of logarithms in the last lesson. So who can recall how to write this as a single logarithm? Log base b of m times n. Very good. When we subtract the logarithms, that's the same thing as doing what? Yes, we're going to divide the numbers m divided by n. And then here you have log base b of m. And there, look, they're using p for power again, just like I did. Okay. The natural log is ln, and remember this is log base e of m. And then when you see log with no base, what can you assume the base is? Log base 10. Very good. So now let's look at a word problem. And this is telling us to round to 2 decimal places. That's code for, if you also saw that, what would be another way to say round to 2 decimal places? Round to the what place value? Yes, the 100th place. Okay, suppose the number of bacteria present in a culture after t hours is given by n of t, that's the number of bacteria, is 15,000 times 2 to the t divided by 2. Is this going to be exponential growth of bacteria or decay? Growth. And what about it says growth? And the base here is 2. Right? So when we have a base that's bigger than 1, we're going to have growth. And it makes sense if you think about bacteria, they're probably growing, right? Unless you have some kind of thing to kill them. All right, so evaluate n of 0 and then interpret what that means in a complete sentence. So n of 0 simply means to plug 0 in. So we get 15,000 times 2 to the power of 0 divided by 2. What's that exponent? Let's start to simplify this. So the exponent, what's 0 divided by 2 as a fraction? 0. What's 2 to the 0 power? 0. Oh, wait. 2 to the 0 power? 1. So we have 15,000 times 2 to the 0 power. We said 2 to the 0 power is 1. And so we have 15,000 times 1. So what does that mean? What is our answer? Yeah. And we were talking about this in the very beginning. We said at the beginning, and that's what n sub 0 is, at the beginning of the time that we're recording this, we have 15,000 bacteria present in the culture. So at the beginning, there are 15,000 bacteria in the culture. Okay. And we were talking about how that number that's multiplied by the base is our starting value. Evaluate n of 3 and interpret your results. So n of 3 means what? What am I going to do to find n of 3? Plug 3 in for what? For t. So we have times 2 to the 3 halves. Okay, if I want to use my calculator, I'm going to type in 15,000 times 2 to the power of, there's my exponent, 3 halves, 3 divided by 2 in my exponent, okay? If you have an older version of your calculator, you might have to be careful about that and put the exponent in parentheses for older calculators just to make sure that you're getting everything into the exponent. I can tell mine is in the exponent because it's up a little bit, but also 3/2 you could put 1.5 as your exponent. Okay, so we have approximately, because we're going to round this off to how many decimal places? 42,426 point. Round it for me to how many decimal places? 2 decimal places, because it had said that in the instructions. And what would you get? 441. Good. Oh, I see. When you were saying 4-1, I thought you meant round it to 4 decimal places. That's not what you meant. Okay, so who can give me a sentence answer then? Come up with a sentence answer. What does the 3 mean? What does the 42,000 mean? There are approximately 42,426.41 bacteria. Yeah, that's kind of a good point, to have a decimal point, but at the same time, it's just following the instructions. They say use 2 decimal places, so I don't really know how scientists measure bacteria and if you can have fractions of bacteria, but that's a good question. How long will it take the bacteria to increase to 62,000? Interpret your results. So am I going to just take this 62,000 and plug it in for t? No. What am I going to do? Yes, this is the same instructions as solve n of t equals 62,000. So you are exactly right. You said take the equation 15,000 times 2 to the t divided by 2 and set it equal to 62,000. Okay, now if I want to solve for t, what do you think I should do first to get t by itself? Divide by 15,000 on both sides. And so I get 2 t halves equals, and actually look at this, I could just reduce this fraction, 62 over 15. I'm going to tell you right now that I would prefer to just leave it as a fraction because otherwise I'm going to have a repeating decimal and I'd have to round, so my answer will not be as simplified. And I mean, maybe this fraction could simplify more too. It doesn't really matter right now. It's just maybe that, let's use that for now. Does that make sense why I would do that as opposed to dividing it? Okay, now there's going to be 2 ways to solve from here. We could use the log base what? Log base 2. You see, because this is the base is equal to the exponent. So you would say log base 2 of 62/15 is equal to the exponent t over 2. Oh, that's t over 2. What did I didn't quite get t by itself. Is there something else I could do to get t by itself? Times 2. Not because of the base 2, but because of the dividing by 2, right? So that would cancel, and we get t is equal to all of this. Now, another way I could have solved it, if I go over here, I'm going to take the same exact problem. And this is very helpful for those of you who have older models of calculators. And it also could be helpful on your calculator as another way to do it. Okay, so we got, this was our problem, 62 over 15. Here's the thing, when we talked about the properties of exponents, if you take this property right here and you want to get the exponent out, you can use the logarithm, right? So if I just say, well, hey, I want to get the exponent out, I want to take the log of both sides. So what that would look like is I would take the log of 2t squared, or t divided by 2, equals the log of 62/15. Okay, now look what happens to my exponent. be using that property of logarithms, I can take the exponent out. So I get t over 2 was the exponent times log of 2 equals log of 62/15. How could I get rid of this right here is multiplied, right? And log of 2, by the way, is just a number. So it's going to be, a very decimally number. Log, I could divide by log of 2. Do you see where that's the same thing? Log base 2 of 62/15 is the same thing as log of 62/15 divided by log of 2. That's called change of base, right? So I get t divided by 2 equals log of 62/15 divided by log of 2. Same thing, I'm multiplying both sides by 2. Okay? So now I'll use my calculator. And remember that I can enter this. If I don't want to put my log base 2 of this number, I can always use the change of base. So I go log of 62 divided by 15, close parentheses, divided by log, not ln, sorry, log of 2. I'm going to push enter. Is that my answer? No, because I have to also multiply by 2. Times 2, and we get 4.09. That's rounded to 2 decimal places. And I didn't really leave much room for a sentence, but what would you say your sentence answer is? It takes 4.09 hours to get, yes, 62,000 bacteria. Okay, I just wanted to show you those two different ways that you can set that up to solve. Now, since I have the number in on my calculator, why don't I go ahead and check it? Okay, I'm going to do a calculator check. That wasn't the check, that was the solve. I just showed you two different ways to solve, okay? So if you were to check, you could take your original equation and you'd be plugging this number in for t. So that would look like this, 15,000 times 2 to the power of, I want to put that answer in, but I don't really want to put the rounded answer in. So if I go second ANS, that's going to put that answer in, divided by 2, and I push equal, and look at that, I get the 62,000 back. That's a way to check it, okay?